Hello, so this is the first part of chapter 2 on chemistry. We're going to talk about atoms and elements. So the first concept in this chapter is the idea of matter. Matter is anything that takes up space or has volume and also has mass. So all living things are composed of matter. Lots of non-living things are composed of matter too. Basically anything you can touch has matter. And something that isn't matter would be light. Light is made up of photons, and photons are particles that we say don't have mass, and so they're not matter. Now, here is a timeline of the discovery of the atom. So John Dalton in 1803 was thinking about what is matter made of? If you broke matter down into the tiniest parts, what would you find? And he came up with this idea that matter is made up of atoms. And atoms are little individual pieces of things that you can't break it down any smaller than that, and that's what everything's made up of. And he said that atoms of certain elements are identical to each other, so all of the atoms of gold look alike, and an atom is the smallest part of an element. J.J. Thomson in 1904 proposed a slightly different model of the atom, so we started to realize that atoms could actually be broken down into smaller component parts. We call those parts subatomic particles because they're smaller than an atom, so they're subatomic. J.J. Thomson realized that there were negative electrons, and there was also a positive component of the atom. Ernest Rutherford added to that idea in 1911. He realized that most of an atom was actually empty space. So he discovered that there's a small positive nucleus in the middle of the atom, that the little tiny electrons, he said that they were orbiting around the outside, but that most of the stuff in the middle was like nothing. Niels Bohr added to his idea by talking about this planetary model of the atom. So we still have a positive nucleus in the center of the atom, and we have these little particles called electrons that he said were orbiting around the nucleus in these different, what we call energy levels or electron shells. So he said different electrons have different energy levels and they orbit around the nucleus in these energy levels, kind of like planets around the sun, and that's this planetary model. Then Erwin Schrödinger proposed the quantum model of the atom, and so now we know, this is still the model of the atom that we use, so now we know that yes, there are these different energy levels for electrons and these like electron shells around the outside of the nucleus. We'll get to that later, but we can't actually tell exactly where an electron is going to be at any given moment. We know that there's a high probability that it is within a certain shape around the nucleus, but it's not orbiting in these nice orderly circles. It's just kind of randomly bouncing around within that space. So we call those electron clouds, and you can see there's sort of that sort of hazy depiction around the nucleus represents an electron cloud. So again, matter is made up of atoms, and now we know that atoms are made up of subatomic particles, and there are three subatomic particles that we're going to talk about. There's protons and neutrons. Those are the particles that are in the nucleus in the middle of the atom. And then there are electrons, which are little tiny negative particles that are around the nucleus in the electron cloud. Let's skip that slide. Okay, so these subatomic particles, the proton and neutron, that are the little particles in the nucleus, they both have a mass of approximately 1 Dalton. So Dalton is the unit that we use to measure the mass of these subatomic particles. It's kind of like saying a gram or a pound, but it's just a really, really, really tiny unit of measurement. So protons and neutrons both weigh about the same, and we say they both weigh 1 Dalton. Electrons are so tiny that they weigh about 1/2000th of a Dalton. So it's such a small amount that we say that it's negligible, like we can just kind of ignore it, not worry about it. So we say that electrons have a mass of approximately 0 Daltons. The proton, in addition to having masses, these particles have charges or no charge. So protons are positive, pro being kind of a positive prefix, right? Protons have a charge of +1. Neutrons have a 0 charge, they're neutral. Electrons have a charge of -1, they are negative. And in an atom, you normally have in a neutral atom anyway, you have the amount of negative charges and the amount of positive charges adding up to being equal so that they add up to 0. So say you had an atom with 5 protons in the nucleus, it would have a charge of +5 in the nucleus. It would have 5 electrons around the outside because that would be a -5 charge around the outside, and that +5 and that -5 would balance each other out. So an atom with 22 protons would have 22 electrons if it was a neutral atom. When you get more or fewer electrons than protons, you're called an ion. So if you're not neutral, then you're an ion, and we'll talk about that in a little bit. Okay, so let's talk about, we talked about what an atom is. An atom has a nucleus, it has electrons, a nucleus that contains protons and neutrons, it has electrons that are bouncing around outside of the nucleus. So what is an element? An element is an atom that has a certain number of protons. Basically, all atoms of an element have the same number of protons. So here is the element hydrogen. Hydrogen is the first element on the periodic table. It has 1 proton, and all atoms of hydrogen have 1 proton. They might have a different number of electrons, they might have a different number of neutrons, if they're an atom or have a different mass, but they're all still hydrogen because they have a single proton. And when an atom has the same amount of protons but different numbers of neutrons, meaning it's the same element, but it has a different mass, then it's called an isotope. So these are 3 different isotopes of the element hydrogen. The first one has 1 proton, and it has a mass of 1 because the proton has a mass of 1, the electron has a mass of essentially 0, so it's got a mass of 1. The second one in the middle, deuterium, has 1 proton, so it's still hydrogen, but it has 1 neutron, which gives it a mass of 2. And the one on the right is still hydrogen because it has 1 proton, but now it has 2 neutrons, and so it has a mass of 3. So isotopes have the same number of protons and are atoms of the same element, but they have different numbers of neutrons, and so they have a different mass. Another way to think about an element is that an element is a substance that can't be broken down into other substances by chemical reactions. So I'll show you sodium here. This is like a sodium metal. That's pure sodium. No chemical reactions that we do to that will break it down into anything other than sodium because sodium's the only thing that's in there. On the other hand, if we had like sugar, which is made up of carbon, hydrogen, and oxygen mixed together, we could do chemical reactions to separate the different components of sugar. But sodium's just sodium. If you break it down to the smallest part that behaves like sodium, it's going to be a sodium atom. We'll do a quick look at how the periodic table is organized. We're not going to go over the whole thing, but just to show you that the periodic table of elements is organized by the number of protons that the element has. So the first square in the upper left-hand corner there is hydrogen with 1 proton. The second one in the upper right-hand corner is helium. Helium has 2 protons. The third one is lithium, which has 3 protons, beryllium with 4, and so on. And you just go in order. Each time you go to the right a square, you're adding a proton. So when we look at the periodic table, it is useful because it tells us things about each element. And 2 of the things that it tells us are the atomic number of each element and the atomic mass of the element. So the atomic number is the number of protons that an atom of that element has. So again, with hydrogen, it's 1. The atomic number is 1 because there's 1 proton per hydrogen atom. The atomic mass is the number of protons plus the number of neutrons, because each of those weighs 1 Dalton. So if you want to know how much an atom weighs, then you want to know how many protons and how many neutrons it has, and that gives you the atomic mass. Here's the example for sodium. So sodium has an atomic number of 11 because it has 11 protons. And sodium has an atomic mass of, on average, 22.990. So let's say we had one atom of sodium that had 11 protons and 12 neutrons. 11 plus 12 equals 23. That would give us an atomic mass for that atom of 23. The atomic mass that's shown on the periodic table is the average of the atomic masses of all the different atoms of sodium. So remember, there's going to be different isotopes of sodium. Some sodium atoms are going to have 12 neutrons. Some are going to have 13. Some are going to have 14. And so when you take, 1,000, a million sodium atoms, and you average the masses of all of them together, you might not get a perfect whole number. So you'll get something like 22.99. Of the elements on the periodic table, only 92 of them are found in nature. The other ones have been created in a lab by scientists that wanted to know what happens when you add another proton, what element do you get? And another proton, what element do you get? And a lot of those man-made elements break down in the lab really quickly. So only 92 elements found in nature that we know of, and about 20 to 25% of them are essential for living organisms. We'll talk about the main ones on the next slide, but first, if you ever hear about trace elements, those are things that are required for life, but just in teeny tiny amounts. So, for example, vertebrates need iodine. Iodine is added to salt for this reason, because you need it for your thyroid gland to work properly. Your thyroid gland is a butterfly-shaped gland on your throat, on the front of your throat. And if you don't have enough iodine, you can get a goiter, which is when your thyroid gets really swollen. So these are the elements that are most common in living things. So the first 4 elements on this table make up 96.3% of the mass of the human body. So that's oxygen is the primary one, carbon, hydrogen, and nitrogen. And the reason that oxygen and hydrogen make up such a huge part of the human body is partly because we are largely composed of water, and water is made up of hydrogen and oxygen. So water is a molecule, it's H2O. We'll talk about molecules later in the next video. And if you break it down into the elements, which is hydrogen and oxygen, then they make up a really large proportion of your body. And then on the last slide here, I wanted to show you that understanding elements in the periodic table can also be useful for understanding medicine. So, sorry, my dog is snoring as usual. The lithium shown here is atomic number is 3. It's got 3 protons. You can see that the mass is about 7, so it usually has about 4 neutrons, depending on the isotope that you're looking at. And lithium, it's interesting because we don't really understand what lithium does in the body. We don't totally get why it works. Sorry, my dog is old. Trixie, stop snoring. Thank you. We don't really understand why lithium works, but it can be used to treat bipolar disorder and depression. It helps, it acts as a mood elevator, but we just don't really know why. So there you go. If you have any questions on this stuff, feel free to reach out. I know it's a little abstract.